Okay, the next section in the second half of chapter 1 of book 3 is translations and shifts. This is an idea that also extends from Calc 1 and two-dimensional graphs. Right, in the journal, you already came upon this surface several times. Hopefully you recognize at this point that this is a cone facing up, wraps around the z-axis. So some of these surfaces you're going to see often. You want to have recognition when you see the algebraic representation that you know visually what the surface looks like. And there are several activities in the second half of chapter 1 of the journal to help you do that. There's some matching contour maps. There's 2 or 3 of those in there that are really good. Visualizations of the surface. And there's one where you do something, you create a Pac-Man cone. So if you're reading along, hopefully you already got your Pac-Man cone. I made mine. And so you cut out one of the pages in the journal, fold it, taped it, and here we have a cone. So if this is the XY plane and this is the origin right here, this is what that z equals square root of x squared plus y squared looks like. And now we're going to ask ourselves what's something that's very similar. Suppose we look at this one. Still a nonlinear surface in 3-dimensional space, 3 variables are used, and we're wondering what does this look like? It has a very similar representation to this cone, so it might be a good guess to say that this is also a cone. And then the question is it opening up, is it opening down, is it around one axis or the other? And what we're going to see that we'll learn how to use tech tools, but we'll also learn, you could probably take a guess, that if this one was around the z-axis, this one's going to be around the positive y-axis. And so we can quickly draw a sketch. So this one look like that around the z. And our y equals 1 is going to be hugging around the positive y-axis, which is here. So it look like that. Again, so relationships between graphs that we know, and then we'll wonder what shifts might do. So back to the first one. Suppose we did z equals the square root of x squared plus y squared plus 4 on the outside. What does that plus 4 do? Well, again, think back to things you know from 2-dimensional space. What did a plus 4 do in just 2-dimensional space? It shifted something up or down the y-axis. So now it's going to shift it up or down the z-axis in this case. Oops. So this is now, the top graph begins at 4. And it's a cone hugging the z-axis, but shifted up 4 units. So there's several pages in this section of the journal that teach you about these shifts and translations and how these are related to the original one. Let's look at one more. Let's look at x equals negative 4 y squared minus 8 z squared. Okay, as it's written, maybe you don't recognize it as one of the familiar surfaces that you've seen repeatedly at this point in chapter 1, but maybe we'll just take out the minus sign and see what happens, and maybe it'll look a little more familiar. Okay, maybe that does start to look familiar. If not, let me write one over here on the side. Hope we can still fit this in. Yeah. Let's write one. Z equals, that we've seen a few times already this class. This is a circular paraboloid opening up around the z-axis. A little mini picture of it. Rounded. And if we stuck a negative sign in front of that, it's now going to go down. It just takes all those z values and shifts them down. So it would just be a circular paraboloid, rounded, hugging the negative z-axis. Now, what if in ours we have a 4 and an 8? They're not just invisible ones in the coefficients. So instead of making a circular paraboloid, if I was to take the original one and say maybe 2x squared plus y squared, this is now going to take that circular paraboloid and squish it one way or the other way, to make what's called an elliptic paraboloid. Okay, so it would still be an elliptic paraboloid hugging the z-axis. And so what do you think happens here? This is an elliptic paraboloid because the y's and z's are competing, right? They don't have the same value. Otherwise, it would be circular if they were both sharing the same coefficient. Elliptic paraboloid facing along the negative, is the negative sign, around the negative x-axis. Okay, so that's the idea of translations and shifts. And then the next video, we're going to check what we think is happening with these translations and shifts by using tech tools to visualize this as well. So again, key summary here. Hopefully you recognize commonalities and certain algebraic similarities between algebraic functions. And you'll see things that are common are cones, circular paraboloids, spheres, ellipsoids. Again, the ones that you'll see in the contour matching sections of chapter 1. So you have several activities that help bring this to the forefront of your mind so you can recognize them instantly by their algebraic structure. Once you recognize that, then maybe you see that, oh, this is just a shift or shift up or left or right or inverting it down of a common surface I already know, so I don't even need a contour map to graph this. This is simple. I've got it. And then you can check your hunch by using a tech tool. Again, that's coming soon.